Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on November 26, 2025, just 2 days ago. It shows that by moving reward feedback learning into the noisy latent space of video generators, the method both improves alignment with human preferences and makes training at least 1.4 times faster while cutting memory use. The paper is titled, Video Generation Models Are Good Latent Reward Models. And as we will see later, the shift to latent space rewards has surprisingly big implications for how we train future video models. Figure 1 gives a visual teaser that process reward feedback learning produces smoother, more coherent videos from both images and text prompts. The small schematic at the top left sketches how a latent reward model steers the video generator during denoising. Surrounding that diagram, the grids of frames show people walking, playing music, or celebrating, and these sequences look natural because motion and anatomy stay consistent across time. Figure 2 contrasts the old training loop with the new one, showing why latent rewards make video alignment faster and cheaper. The top row sketches standard RGB reward feedback learning, which must almost fully denoise, run through the VAE decoder, and only then score the video, so gradients are late and memory heavy. The bottom row illustrates process reward feedback learning, which samples a random time step, takes just one denoising step, and sends gradients directly from the latent reward model, giving fast sampling and supervision across all stages of generation. Figure 4 explains how the method actually wires a latent reward model into the video generator. The left panel shows the reward model reusing early DT blocks from the video generator, then applying attention and a small head to turn noisy latent features into a single quality score. On the right, the top row trains this reward model from human preference labels, while the bottom row shows process reward feedback learning, which updates the video generator directly in latent space at random time steps, so motion and structure improve throughout the whole denoising chain. Figure 5 shows that people clearly prefer videos from process reward feedback learning over other post-training methods. Human evaluation here means viewers watched paired clips and chose which one better matched the prompt and overall quality. Across all three baselines, process reward feedback learning wins around 2/3 of comparisons, while the competitors only win about 1/5, which signals a strong real-world quality gain. Table 1 and Table 2 show that process reward feedback learning consistently upgrades motion and anatomy without hurting other qualities. Across both text-to-video and image-to-video benchmarks, the method dramatically boosts dynamic degree and human anatomy scores, especially at higher resolution, while motion smoothness and subject consistency stay near the pre-trained model. The average improvement is roughly 9 to 11 points, which signals much more lively yet still stable videos. These gains appear across multiple datasets, so they likely generalize rather than overfitting one test set. So the big lessons are that latent space rewards let video models learn motion and structure directly during denoising, and they do it with less compute while people clearly prefer the results. This points to process-level alignment as a practical path for future video systems. That is it for this episode of AI Research Roundup. I am Alex. Thanks for listening.